Welcome to Honors Geometry 10.6 segments and circles. Okay, this time we're going to talk about segment lengths and how they interact in segments as they interact with circles. We won't be looking at angles, it'll be all about segments. So let's go ahead and talk about the segments of a chord. Go ahead and write that down. I don't really know if I want to say it at all, but just know that when two chords intersect, you end up making four segments. And the green and red are the two segments of chord AB. MD and DN are the two segments of chord MN. Alright, hopefully you got that all written down. I'm moving on. Alright, this is how we typically do it. I just introduced some new vocabulary, and what do I do next? Throw a theorem at you. What this says is that if two chords intersect each other inside a circle, that the segments of one chord find their product, and they should equal the product of the two segments of the other chord. So the green part times the red part equals the blue part times the black part. Segments one multiplied together equal the segments of the other multiplied together. Okay, segments of secants. Okay, go ahead and write that theorem down in words, and then I'll explain it with colors and everything. So go ahead and pause it. Alright, welcome back. What the segments of secant's theorem says that if you multiply the length of one secant segment times its external part, so mx times the outside part ma or am is going to equal the the other secant segment my times its external part bm. That's the secants of segments theorem. Got one more that could possibly happen. It's going to be a secant segment and a tangent segment. And here it goes. Okay, so the whole secant segment my times its exterior part bm equals, and then the tangent segment am, since it's the full length and the outside part, it'll be am squared. Alright, I hope you paused those and wrote those examples down. Especially people like Evan. You know, you don't like to write down the examples. You should be writing all these down. Alright, I'm moving on. Alright, here's our first example. It is the segments of a chord theorem. So, wow. 6 times 6 equals 4 times x. 36 equals 4x. Missing part right here, 9. Alright, let's look at the next example. Make that go away. Come on up. What do we got here? Okay. You have x times x. Wow, you know what? I just realized you probably can't see that, can you? Let me move it over there. Alright. Keep on forgetting about my face being in the way. Alright, here we go. You have x times x equals let's see here, x plus 4 times x minus 2. So you got x squared equaling, alright, x squared. You got plus 4x and minus 2x plus 2x, and then you got 4 times negative 2 minus 8. So subtract x squared from both sides. 0 equals 2x minus 8. 8 equals 2x. X equals 4. Okay, next examples. You have, okay, the first secant is 12 times the outside part 4 equals, the second secant is x plus 6 times the outside part, which is 6. So 48 equals 6x plus 36. Subtract 36 from both sides, and you get 12 equals 6x. Divide both sides by 6. 2. Alright, let's grab that second example. Come here. And we'll extend the page, and then we'll open this puppy up. Okay, here we go. The first chord, you're adding them together, so that would be 2x plus 2 times the outside part, x, is going to equal, add those two together, the full length of that secant is x plus 9, no, x plus 7, times the outside part, x plus 1. So 2x squared plus 2x equals x squared. Okay, there's 7, and one more is 8x plus 8x, and then 7 times 1 plus 7. Okay, get everything over on one side. I'll subtract an x squared. X squared. I'm going to subtract an 8x from both sides. Minus 6x. And then I'm going to subtract a 7 from both sides. Minus 7 equals 0. Now we'll factor that trinomial, or that quadratic if you'd rather call it that. Alright, I need two factors of 7. They have to be 7 and 1. Since this second sign is negative, that means these two signs are opposite. And I need a negative 6, so I'll do a minus 7 and a plus 1, because that'll give me plus 1x, and minus 7 for a minus 6x. So x plus 1 or x minus 7. So x equals negative 1 or x equals 7. And if I go back and look at the picture, I don't think x could be a negative 1, because that would make this outside segment a negative, or this one 0, which would not be good at all. So we'll reject the x equals negative 1, and x will have to equal 7. Alright, one more page. Here we go. Okay. Tangent segment and a secant segment. Okay. The whole secant segment is 48 times the outside part, 12, equals x squared. Alright, 48 times 12 is going to be 576, equals x squared. Take the square root of both sides, and x could be plus or minus 24, but a minus 24 makes no sense in this context, so x has to equal 24. Alright, let's do one more example, this time with probably some x squareds in it that don't go away as easily. Alright, here we go. Okay. The length of the whole secant segment is x plus 10 times the outside part, that would be x, equals the tangent segment squared. Whoa, I extended the page a little bit far. So x squared plus 10x equals 144. So get that all on one side. X squared plus 10x minus 144 equals 0. Factor that quadratic again. Got to be an x and an x. Because this second sign is negative, these are going to be opposite signs. Alright, I need two factors of 144 that are 10 away from each other. And those I just happen to know are 18 and 8. So x equals, set this one equal to 0, negative 18, or x equals 8. I don't think it's going to work really well if x is negative 18, because that outside part will be a negative, and that's kind of an impossibility. So we're going to have to accept only the x equals 8. Alright, there's some examples about working with segments and circles. This will conclude lesson 10.6 on its geometry, segments, and circles.